visited Denver, Colorado, the Andes, Tibet, or for that matter attempted to climb Mount Everest, you've probably noticed how much harder it is to breathe. The percentage of oxygen in the air is 21% at sea level and at high altitude locations. But as the air pressure becomes lower at higher altitudes, air becomes thinner and there are far fewer oxygen molecules per breath. The term hypoxia, which is a risk for high-altitude climbers, refers to the condition in which the body is deprived of adequate oxygen.
There's a pathology, a sickness of high altitude that we call acute mountain sickness, and you can start to feel the effects of that within hours of arrival at high altitudes. So headache, nausea, it's not uncommon for people to start vomiting and so forth. And this is something that people who go skiing, for example, in Colorado, experience.
Then again, if you've lived all of your life at a high-altitude location, you may have the luxury of looking down your nose, literally, at those who struggle to breathe as they distance themselves from the oxygen-rich embrace of sea level. It is no mystery that some people acclimatize, that is, change in response to a new environment, more easily than others. Acclimatization to a higher altitude can require days or months and includes an increase in red blood cell production.
And certainly from personal experience, I remember climbing a mountain, one of my first big mountains, and having taken 6 or 7 hours puffing and panting to get maybe a distance of only 500 metres. The next morning there was an emergency and I had to take someone down the mountain as the doctor, and then I had to get back up quickly before a storm came in. And I made the distance that had taken me 6 or 7 hours one day. The next day I made that in 40 minutes. So in brief, what we think is happening now is that it's not so much about delivery, it's about the efficiency with which you burn the oxygen. And then in fact, this is a metabolic issue.
But acclimatization is not the whole story. Scientists are discovering another process of becoming better suited to life at high altitudes. That is, while each individual may acclimatize more or less easily, populations have adapted, or not, to life at 2,000, 3,000, or even 4,000 meters. One important life process made more difficult by hypoxia is pregnancy. For both mother and baby, a high-altitude environment presents complications, so successful pregnancies and births often indicate better adapted people.
You do find quite marked differences between racial groups in terms of birth weight. So you will find native Andeans, for example, will protect a higher birth weight than people who are of, say, more lowland ancestry.
So we asked the question by surveying everyone in 14 different villages at high altitude in Tibet. We measured oxygen saturation. It's easy to measure non-invasively, that is without taking blood samples. And we also asked all of the women about their fertility histories. And astonishingly, we found that the women estimated to have the high oxygen saturation genes had more than twice as many living children. This is a very strong indicator of natural selection.
Scientists believe that genetic research is a key to understanding how some indigenous populations thrive at higher altitude, lower oxygen level environments. At the 2009 Hypoxia conference at the National Evolutionary Synthesis Center, many discussed their research into how particular genes have evolved to cope with mountain life.
We're all familiar with those images of the indigenous people of the Himalaya and their ability to perform on the highest mountains in the world. They seem to have this innate ability to climb higher, harder and faster than other individuals who visit the region. So it's trying to understand how their genomes and the diversity within their genomes is allowing them to do this.
But is there a trade-off? Do populations adapted to high-altitude life fare worse when they migrate to sea level?
One of the things which probably I would expect might occur is exposure to pathogens that they hadn't otherwise experienced. The temperature variation from day to night is great enough that most bugs get fried in one form or another. As populations are more susceptible to infectious diseases, simply because they haven't been exposed.
You've been reading Between the Genes with Katrina Voss.